Hello and welcome to Finance World. In this video we are going to continue with the topic of geometry, and we are going to explore what quadratic equations look like when they're plotted on some graph paper. First off, we are going to revisit the method of completing the square, because if you have a quadratic equation of a form ax squared plus bx plus c is equal to 0, you can actually complete the square and rewrite the above as x plus a half b divided by a all squared minus b squared divided by 4a squared plus c divided by a is equal to 0. Now, what does this actually mean? What we're going to do is we're going to revisit the worked example when we had completed the square. The quadratic equation we solved was x squared plus 10x plus 6 is equal to 0. When we completed the square, we obtained the equation of x plus 5 all squared minus 19 is equal to 0. This form of the quadratic equation tells us a lot of information about the graph. Okay, from the below, let's observe several important coordinates. When you have x plus 5 all squared minus 19 is equal to 0, you can solve for x and obtain the coordinates where the 2 points intersect the x-axis. Okay, when you do that, you would obtain minus 5 plus the square root of 19 and minus 5 minus the square root of 19. Now, as those two x values intersect the x-axis, we obtain two coordinate points. Okay, and then you also have, from solving x plus 5 all squared is equal to 0, this is where the maximum or the minimum of the graph can be found, and that's what we call the vertex. You have minus 5 and minus 19 is the vertex of the graph. And what do we mean by vertex? The vertex is the turning point of the graph. So this graph looks exactly like this, where the 2 points, minus 5 plus root 19 and minus 5 minus 19, are the 2 points there where it crosses the x-axis, and minus 5 minus 19 is that turning point on that graph. Now, this means that when you complete the square, you can actually get more information than just solving the equation using the quadratic formula, because you get the extra component of the vertex, the coordinates of the vertex. That means for any generic equation you can have of the form ax squared plus bx plus c is equal to 0, you can rewrite this by completing the square into this form that we had early in the slide. Now, if you collate the constant terms together, you get a b squared plus 4ac divided by 4a squared. That means you can observe that at the points minus b minus the square root of b squared minus 4ac divided by 2a and minus b plus the square root of b squared minus 4ac divided by 2a are the coordinates that crosses the x-axis. Now, you'll recognize this from solving the quadratic formula, and you'll also have a new point where you have minus b divided by 2a and minus b squared minus 4ac divided by 4a squared is the vertex of the graph. Let's actually illustrate this using the same example, but now we're just going to fill in these coordinates using a equals to 1, b is equal to 10, and c is equal to 6. Let's first start with the two coordinate points that cross the x-axis. With a equals to 1, b equals to 10, and c equals to 6, you can now put in those numbers into those 2 points where we expect to cross the x-axis. So we have minus 10 minus the square root of 10 squared minus 4 times a times 6, all divided by 2 times 1, and you have minus 10 plus the square root of 10 squared minus 4 times 1 times 6 divided by 2 times 1. Let's fill in the numbers. So you have minus 10 minus the square root of 100 minus 24. That's square root of 76. All divided by 2. And you have minus 10 plus the square root of 76 divided by 2. Okay. So we know that 100 minus 24 is the square root of 76. And you have minus 10 minus the square root of 76 divided by 2, and minus 10 plus the square root of 76 divided by 2. Note you can rationalize this, so square root of 76 is equal to the square root of 4 times the square root of 19, so that's equal to 2 root 19. Let's put that back in instead of root 76, so we have minus 10 minus 2 root 19 all divided by 2, and you have minus 10 plus 2 root 19 all divided by 2. So that means we have minus 5 minus the square root of 19, and minus 5 plus the square root of 19 is where it crosses the x-axis. And those are the two coordinate points there, as we expected. Now, using this same numbers again, we can now try and find the vertex of the graph. By putting in the numbers, you obtain minus 10 divided by 2 times 1, and minus 10 squared minus 4 times 1 times 6. Divided by 4 times 1 squared. So you have minus 10 divided by 2, and you have minus 100 minus 24 divided by 4. So the top bit is 76 again. So you have minus 5, and 76 divided by 4 is 19, so you have minus 19, and that's the vertex of the graph. And that's exactly what we expected it to be as we completed the square earlier on in this video. Okay, so what we have coming up next will be the equation of a circle. We'll also have a look at angles, trigonometry. Then we'll explore calculus. We'll derive calculus from first principles and look at differential calculus. We'll revisit some algebra, which is solving simultaneous equations, where it could be a system of a quadratic plus a linear equation or two quadratics. And we'll have a look at some more special cases of quadratic equations. So if you've liked the content, please like and subscribe. If you have any queries on the content that I've delivered, please leave a comment down below and we can discuss this further. For now, please stay safe and peace out.